right, now we're going to talk about Chapter 15. Chapter 15 basically throws a ton of information at you about advanced statistical procedures that are too much for us to do in this class. We're not going to work out any examples of any of these things, but it's kind of an awareness of, if you keep going with statistics, these are the types of things that you can do. And I think in your senior seminar class, you might revisit some of these ideas. I've never taught senior seminar, so I'm not certain, but I believe you do. But so I wanted to go through, I've made notes, and hit on some key points from Chapter 15 and explain some of these procedures and their application in just a little bit different detail than how your textbook did it. So again, with the pop-ups, good grief. Okay. So first and foremost, one that I want to start with is the concept of Chromebox Alpha. This is a very interesting statistic that is used a lot in item development, scale development, but it's also used a lot in education because it's a very valuable tool in seeing if you're writing good tests. So if any of you are planning on going into any field of teaching, this is something to pay attention to. So when you develop a survey, for example, you don't just, you do, but you want to be careful about just writing down a bunch of questions and giving it to people and saying, oh, hey, look, I've developed a new happiness survey. All right. There are tests that you want to go through to see how reliable your survey is, meaning how much are each of those items fitting together well to give you a reflection of the big picture that you're wanting to get. So it's an evaluation of reliability. It's an evaluation of the consistency of the answers that you're seeing. Because let's say I put together this, I think we actually already did an example of this earlier in the class when you're talking about a depression inventory, where there was a 10-item version of it. I'm probably totally remembering this wrong. But there was a 10-item version of it, and they realized that one of the items just wasn't that helpful in terms of evaluating current depression symptoms, and so they reduced it to a 9-item, if I'm remembering correctly. That was the scenario. We talked about it way back at the beginning of the semester. And that's an example of when you would use Chromebox Alpha, right? If I develop a 10-item questionnaire that I believe is measuring happiness, and I run an analysis, and here's this one question that's really not relating to the other questions well, it's not relating to the overall score of the test well, then I might need to look at that question and say, okay, how well is this question that I'm asking actually contributing to the overall evaluation of happiness that I'm trying to get to? Is this a bad question? Should I throw it out? This works similarly with tests, because what I can do is I'm giving you an exam. I, as the teacher, am giving you this exam over this thing. And I can run a Chromebox Alpha and determine, is my test fitting together well? Are these answers cohesive? Do highs go with highs and lows go with lows? In terms of, am I measuring what I'm hoping to measure by giving you this test? Just for the fun of it, because, I'm that particular breed of nerd. Just for the fun of it, I ran a Chromebox Alpha on our midterm for this class from a couple weeks ago. And what came back was the Chromebox Alpha for the midterm in this class was a 0.9276. And I have not told you yet what those numbers mean. So within Chromebox Alpha, what you're doing is you're looking at the number of test items, and you're looking at the level of correlation among those items, and then how that fits together as the whole. So you're looking at how well are these items related as a group, and you're to assess some common characteristic. And so according to your textbook, a good Chromebox Alpha is 0.6 or higher, and an ideal Chromebox Alpha is 0.9 or higher. Some argue that 0.7 should be that cutoff for acceptable, and that 0.6 to 0.7 should be viewed as kind of questionable. So just so you know, there is some argument about that. But anyway, the Chromebox Alpha for the stats midterm in this class was a 0.9276. Meaning that's an excellent Chromebox Alpha score, meaning those questions fit well together. If I could say I have put together a reliable measure of how much knowledge you had about statistical procedures at the midterm point of this class, the numbers fit well together. If I would have thrown in a random question about the Civil War and a random question about zoology, that would have lowered my Chromebox Alpha, right? Because that wouldn't be related to what I was trying to measure. Getting those questions right would probably not have had a very high correlation to getting the questions right about how to evaluate the statistical significance of a t-test, right? Totally different ballgame about what we would be measuring. So, however, another class that I'm teaching this semester, just for comparison, I ran a Chromebox Alpha on those scores. And that one came back with a 0.438, which is a problem, right? That is not a good score. So that tells me for that test, for that class, I need to go in and try to figure out, why is this test so unreliable? Why are the scores in this test so all over the place that I did not get a reliable correlation between my test items in the way that I would have expected to? Now, this does get into one of the next items that your chapter 15 discusses, although they skip around a little bit, which is the idea of a factor analysis. The idea behind a factor analysis is where you say, I have this one test, I have this one survey, I have this one measurement, I have this one questionnaire, but I'm expecting that there's actually multiple things being measured by it at the same time. So viewing it as a whole might not be the best way to do this, but maybe I should view it as a whole that's made up of these different subsets. And those different subsets are called your factors. And there is a statistical analysis that you can do with that to put in your test data, put in your item data, run it through, and it will tell you, like the machine will do all the calculations for you, and it will tell you, it appears that you have 3 factors in your data. To give an example, let's say I gave a questionnaire about overall life satisfaction. And within that questionnaire, maybe I had questions in there about your family relationships, your romantic relationships, your engagement in hobbies, your physical well-being, right? Do you have a chronic illness that you suffer from? Do you have something that on a regular basis you don't feel well, such as persistent migraines or a digestive condition or a chronic pain disorder or something like that? Okay. And I'm labeling this as, this is an overall life satisfaction inventory. And let's say that comes back with a really crummy Chromebox Alpha. Well, the reason for that is probably, yes, I can argue I can combine all of these things into one measurement to get one number, but realistically, I'm measuring some very different things here. So I could run it through my factor analysis and it would say, hey, you appear to have 5 separate measurements happening here. And then I would look at those 5 separate measurements. And I, as the designer of this test inventory questionnaire, would say, oh, okay, so these items, because what factor analysis is doing is telling you which items are grouping together and how many groups are being formed. So I would look at that and say, okay, these items are grouping together, and these are all kind of about socialization. These items are all grouping together, and these are all kind of about how do you feel on a daily basis. These items are grouping together, and this is dealing with life enjoyment, about, do I have hobbies? And so these are loading on here. And so I would have these factors, and then I would have these items loading on each factor. And then I would probably want to do a Chromebox Alpha for those factors instead of the test as a whole. So that test that I gave in my other class, I had that really crummy 0.4 something Chromebox Alpha. I look at that and I say, okay, this test was over 3 separate chapters that weren't really about the same information. They were 3 totally separate concepts. And each of those chapters was divided into multiple subsections, and some of them weren't totally cohesive the way the textbook did it. So I'd want to look at that and say, maybe it's not a good idea to look at the alpha of this whole test, but to separate the questions for each chapter. because maybe the understanding of this chapter was not very well correlated with the understanding of this chapter because they were so separate, or because this is a super busy time in the semester and everybody had a chance to read one chapter but not the other, or whatever it might be. So that is the practical application of Chromebox Alpha, and how sometimes an alpha and a factor analysis can go together. Because if I have a really crummy Chromebox Alpha, I might want to do a factor analysis to see if my inventory is measuring more than one factor. Now, as a clarification, you do not have to, it's not like a post-hoc test, okay? So you don't need to have a crummy Chromebox Alpha to justify, let me do a factor analysis. Anytime you give if you're developing a new survey, if you're developing a new questionnaire, lots of applications, it can be a good idea to do a factor analysis just to see, am I measuring what I think I am measuring? All right, so that's Chromebox Alpha. The next topic in chapter 15 that I wanted to do a quick overview of is the idea of the general linear model. And you say linear modeling, and then you're just getting into a whole separate branch of statistics, because there is linear modeling, there's hierarchical linear modeling, there's multi-level linear modeling, there's structural equation modeling. There's a whole nother world of this stuff. And it is very interesting and very complicated. So in a nutshell, a general linear model is you're saying, I can divide the impacts on any variable I'm interested in into three broad categories. There is fixed influence, and that's something that's the same for every participant that I have, okay? If I give you a test and I'm wanting to evaluate what are the things that impact how you do on the test, I'm giving everyone the same test, all right? So that test, the test questions, the characteristics about that test, that is a fixed influence. I'm giving it to everybody in the same way. I'm gathering you all together in a room and handing you this test, or I'm emailing all of you this test. So that's the fixed influence, is the things about the test. It's the same for everyone. Okay, so that's the first element, the first type of influence we're going to look at. The second type of influence is what we tend to focus on: the influence of the variables that I'm interested in measuring. That I'm interested in measuring, where my participants are going to vary in a meaningful way. If I'm wanting to evaluate how well you did on this test based on how many hours did you study for this test, how many hours do you tend to work in a week, which is probably also going to impact how long you studied for this test, and how much you're enjoying this class. That's that second category. So those are the variables that I'm interested in studying, where I'm expecting everyone to differ, okay? So I have my fixed variables, and I have my variables that I expect to differ, that are my variables of interest. And then the third category of variables that I can account for in a general linear model are what we call our error. And those are things that I am fully and completely acknowledging that here are all of these other variables that could have an influence on how you did on this test. But it's not what I'm measuring. Either I can't, or I'm not, right? And so that's my error line. So if I'm wanting to measure, I want to see if I can predict, because a lot of times general linear models are about prediction in a very similar way that regression was. Regression is a simplified form of a GLM. So I'm wanting to say that I can predict how well you're going to do on this test based on how many hours you work each week, how many hours you studied for this test, what was the other thing, and how much you're enjoying this class. I can come over here and I can acknowledge how many hours you slept the night before the test is probably also going to have an impact. How much life stress you have going on right now is probably also going to have an impact. And I'm including those in my error terms, saying I acknowledge there's other stuff going on in your life that's going to impact how you did on this test, but I'm not measuring for it. That's why this isn't a perfect prediction, That's why I can't put my 3 variables of interest together and perfectly predict how well you did on this test, because I'm acknowledging there's this column over here labeled error that there could be 35 items in. I'm not measuring those. All right. So that's a GLM. Is you're giving that room for error, for things I'm not accounting for that are influencing the variable I'm interested in. But so the overall goal of a general linear model is I want to make a statement about the influences on my variable of interest. Now, let's say I did measure those things. I had measured how much sleep you got the night before you took the test, but I'm not really wanting to consider the impact of that. I'm not wanting this to play into it. This is where the idea of a partial correlation comes in. A partial correlation, something else. A partial correlation is where you're saying, I'm wanting to know the impact of your work hours, your study hours, and your enjoyment of the class over and above the effect of how tired and stressed you were as a whole when you took this test. Okay. So now it's not just, okay, this is this error term that's influencing, it's I have information about this, but I don't want that information to get in the way of me trying to assess this relationship of this variable, of these variables that I'm interested in. And that's the idea of a partial correlation. I am partialing out the influence of these other variables. You'll also see it worded as I am controlling for these variables. So I am doing a statistical technique that allows me to tell the program my dog is very loud. I'm very sorry. This variable right here, I want it controlled for. I want the influence of this held constant and kept away from the influence of these other variables. Your textbook gives a really interesting example on page 625 of a study that did this in analyzing suicide attempts, suicidal ideation. And what they had looked at was that there was long-standing research findings saying that a prior suicide attempt was likely to predict future suicidal ideations. And the concern that had been brought up about these research findings is, okay, but that might be making it a little bit too simple. Maybe it's pervasive depression, that somebody was very depressed and that had led them to their first suicide attempt, and they just had never gotten effective therapy, effective treatment for that depression. So it continued, and that made them more likely to try again in the future, or to at least think about trying again in the future. It wasn't the fact that they had done it before that made them more likely to do it again. It was that depression going on underneath here had never been fixed. And so the researchers decided to do a study where they took a bunch of other variables. Your textbook lists it out. I pulled up over the study pulled up right here. They controlled for, right? So they told their statistical analysis to hold steady this influence and remove it for age, gender, relationship status, race, ethnicity, a family member who had committed suicide, the presence of a mood disorder, depression or bipolar disorder, the depression of substance abuse, the depression of a personality disorder, legal troubles. Like, they took all of these things and they told their statistical analysis that they did using their computer software, we have numbers for these. We have values for these. Remove the influence of those variables and let's see if a past attempt still predicts a future attempt or future ideation. And what they found was removing the influence of all those variables only made the slightest decrease in that relationship, and not enough that it removed the statistical significance. So what we would have expected to find if that relationship could have been explained by the depression was, once you remove the influence of depression, this relationship is no longer significant. That's what you would expect to find if depression was explaining the relationship. And that's the value of being able to do a partial correlation, being able to control for a variable, is to have the power to say, this might be having an influence. Let me remove that from my analysis and let's see what happens. So the much more simple and less sad example that I had given about the test scores, if I had said, I want to remove how tired you were, how much sleep you got last night from this example, if my three variables were still having a significant impact on your test score, I would know, okay, this isn't, you being tired isn't having enough of an influence that it's removing the significance of these variables. If I removed that and now one or all of these variables were no longer significant, I could say, okay, so the bigger explanation here is that you were tired. Maybe that's why you didn't study as much, right? Maybe that was the influence between study hours being low. It's not that you didn't study enough for the test. It's that you've had a really exhausting week. You're exhausted and you were too tired to study for the test. And the issue was not the studying. The issue was tiredness and the brain fog while taking the test, whatever it might be. Point being, a partial correlation allows us to have the statistical power to look at a variable and say, I know that this is probably playing a role over here. I want to reach over and take that out and see if that, removing that factor, removing that variable, removing that influence is going to in any way change the relationship that I'm expecting to see between this variable and this variable. And that leads us into the idea of a mediational model. If you have taken methods, research methods, the term mediator should be already familiar to you. The idea of a mediator is a variable that is explaining the relationship between X and Y. Okay? The suicide example that we had talked about, the argument that was being proposed is that depression was functioning as a mediator to explain the relationship between a past suicide attempt and a current suicidal ideation. That the explanation between these two variables was the presence of depressive episodes between those two variables, between the time points of those two variables. So mediator variable is me saying, all right, I see the numbers that X is related to Y. But I think that there is another variable that goes right here in the middle that's explaining that relationship between X and Y. And we talked about that earlier this semester, right? That maybe the relationship is not between, I think we used the example of like free time and overall presence of free time and overall stress levels or something like that. That the relationship, okay, that's there. Free time is related to stress levels. Or no, we talked about exercise and stress levels. But okay, yeah, that relationship is there between exercise and stress levels. But I'm proposing that what's explaining that is the free time, right? That it's not a direct relationship between exercise and stress. That it's actually an issue of having free time. That's what's going to be the true explanation here. And that's the idea of a mediational model, is I have these two things that are related, and I'm trying to find something in the middle to explain why. Or I'm proposing that maybe looking at that relationship as a simple line is not accurate, is far too simplified, that I need to acknowledge something else is happening in the middle of that. And that is a mediational model. And mediational research I personally find fascinating. All right. So 2 other points from chapter 15. The idea of a hierarchical linear model or a multiple level model is where, first and foremost, you have 2 different types of effects that you're looking at. You have random effects and fixed effects. A random effect is a variable that I'm including in my model because I know that it has an impact, but it's not what I'm focusing on. And I'll give you an example once I explain a fixed effect. And a fixed effect is the variable I'm interested in, the predictor that I'm interested in. So within my model, okay, I'm trying to explain my dependent variable. I have my independent variable, my predictor variables, okay? And so I'm trying to explain these over here. My random effects are things like maybe age or gender or marital status. I know that those are having an impact on this variable I'm interested in measuring, but I'm not interested in them for this study. I'm including them because I know they have an effect in my modeling data analysis. Excuse me, in my modeling data analysis, I'm including them because I know they have an effect, but it's not what I'm studying. Okay, so within a multi-level model or a hierarchical linear model, you have those two different types of effects that you include. The purpose of an HLM or an MLM is that you're basically saying my participants, I'm trying to think of the most straightforward way to word this. My participants are not all independent of each other. I can divide them into groups. I can divide them into hierarchies. I can divide them into layers. Okay. I'll give you an example. I used to live in a large city, and when I lived in that large city, I worked for a large community college system within that city. There were 10 separate branches of the community college that made up this overarching community college system within the city. Now, let's say that somebody wanted to come in and do a study of job satisfaction among faculty members for this college, and they were wanting to look at different variables that could play a role. This would be a great example of something we might use a hierarchical model for, because you would need to look at the departments within each college, because there's its own department chair, which is basically like its own boss of each department, right? So you need to look at each individual department. And then you would need to look at each of the 10 colleges because they didn't all function the same way. And then you would look at the overall college district because maybe you're wanting to compare the community college district in this city with the one in another large city. And so you would have these groups, these layers, these nests where you would need to look at the psychology department of college number 3 within this college system. It wouldn't really be accurate to look at all the psychology departments of all 10 colleges as a whole, because there was some very different operational methods between each one. But it also wouldn't be accurate to look at faculty satisfaction with each one as a whole, because there's very different divisions within each college, right? If I was wanting to do a survey of employee satisfaction of employees that worked for AT&T, I'd probably want to make quite a few divisions. I might want to look at the difference between, do you work for sales or do you work for tech support? Do you work for store number 327 or store number 330? Because maybe they're in the same city, but they have very different managers with very different management styles. The overall district, are you in the Missouri network of stores or are you in the Minnesota network of stores, right? So the idea of hierarchical linear modeling, and your textbook uses the example of classes, looking at the classes within the department, within the school, within the district. I'm acknowledging my participants are not all independent of each other. I can nest them within these kind of growing groups. And I need to consider those divisions as I'm analyzing my participants, because there are some influences that will affect certain classes, certain departments. There are some influences that will affect things as a whole. And I need to be able to look at which of these levels of this nesting is this influence going to take place at. And then finally, the last topic of chapter 15 that I want to go over is the idea of structural equation modeling, which you'll have circles and squares and arrows everywhere. It's fascinating and it's complicated. The idea of structural equation modeling is I'm acknowledging there are some variables of interest, and this is very relevant to psychology and behavioral sciences in general. There are variables of interest that I can't truly measure. I can just use my different surveys, my different tools, my different indicators to give a proxy measurement of what that number might be. So we represent those variables of saying I can't truly measure this as a circle, and we call them latent variables. So an example of a latent variable would be life satisfaction. I can't truly measure your overall life satisfaction. It's not something I can capture. However, I can measure, I can give you a survey indicating your occupational satisfaction. I can give you a survey indicating your marriage satisfaction. I can give you a survey, and I'm doing this because each one of those like items or indicators are drawn as rectangles. So you have the rectangles that then go up to the big circles. I can give you a survey that would measure your satisfaction in your hobbies. Another example would be social support. I can't truly grasp your. I have a gnat in here. I cannot truly grasp your social support by boiling it down to a number. It's a complicated concept, right? The support of your family, the support of your friends. Are you plugged in any sort of social network like interest clubs or churches or book club or whatever, right? There's a lot of things that go into this idea of social support. But maybe I can measure your level of connectedness with your close friends. I can measure your level of family contact and connectedness. I can measure your level of perceived closeness with your social groups. And so I could put all of those together and say, because I have these three things, I am proposing that these three things are working together in a way that I am getting an overall picture of what your level of social support looks like. So, level of social support would be the latent variable. And then each of those boxes that I'm actually giving you a survey to measure, or that I have an item, maybe this is measured by adding questions 3, 7, and 12 on the survey I gave you, that I have that item to measure are my observed variables. And that's the basics of structural equation modeling, is that a variable isn't just a variable, that there are levels of observations that make up these bigger picture variables. And that's why it's called structural equation modeling. I'm creating the structure defining, hey, when I say I'm measuring your life satisfaction, here's what I'm actually measuring for this analysis and how this is relating to this. And then seeing this life satisfaction relate to something. So your textbook gives some visualizations with drawing out, because there's only so much helpfulness from me doing all this nonsense. But your textbook actually draws it out where you can see what results would look like. And those are your important key points from chapter 15. And with that, we conclude our Statistics for Behavioral Sciences textbook.